Here's an interesting History Channel clip that didn't bother to ask the Bush administration why they've never brought this issue up in public.
Bursting through the Earth's atmosphere, this giant asteroid becomes an unstoppable force. Nearly 2 million times more powerful than the Soviet Emperor bomb, the largest, most powerful explosive device ever detonated. Its target? Los Angeles. The last thing anyone there sees is a flash, a fireball, and then
if this asteroid were as large as we might imagine, a 10-kilometer asteroid, we would be talking about a crater that is 10 times larger than that. So we'd be talking about a 50-mile crater. So all of Los Angeles would end up being this humongous crater. We'd be talking about absolute devastation, nothing left over, range up to perhaps 100 miles. As far away as San Diego, they would get massive earthquakes, they would get massive air blasts, winds that would simply flatten everything 200 miles away, would kill everything out to a range of perhaps 1,000 miles.
And that's just the immediate impact.
Then you would have all this debris fall back on the planet Earth. It'd be like a Christmas tree, seeing all these ornaments being thrown out in all directions. And then you would see firestorms, enormous areas of the planet Earth burning, releasing even more soot and ash in the air, blanketing out sunlight. Temperatures would then plunge, and life itself would be perhaps extinguished.
What you've just seen is a worst-case scenario of a major Earth impact event.
The kinds of asteroids that can extinguish much of the life on Earth, most of the species, come around every, say, 100 million years or so. And it's not a periodic phenomenon. It doesn't happen every 100 million years. It could happen at any time, just on average, roughly once every 100 million years. So it's not a question of if it'll happen. It's a question of when it will happen.
Asteroids and comets have been crashing into the Earth for as long as there's been an Earth. Soon after its formation, about 4.5 billion years ago, our planet became a frequent target in a cosmic shooting gallery.
Asteroids and comets brought to the early Earth much of the organic materials and water that allowed life to form. Subsequent collisions, like the one that took out the dinosaurs 65 million years ago, punctuated evolution, allowing the most adaptable species, that's us, to rise to the top of the food chain. So we owe our very existence and our position to these objects that sometimes cause a threat.
According to the Earth Impact Database, more than 160 impact craters have been identified. The largest one is called Chicxulub, Mayan for Tail of the Devil. This crater measures more than 110 miles in diameter. It was made by the asteroid that took out the dinosaurs when it crashed off Mexico's Yucatan Peninsula. Closer to home, the database also includes Meteor Crater in northern Arizona. Now a tourist attraction, this kilometer-wide hole was left by a huge chunk of cosmic iron ore that collided with Earth about 50,000 years ago. Much more recently, an enormous near-Earth object didn't leave a crater, but still made quite an impression. Packing the energy of a 15-megaton bomb, more than 1,000 times that of the one dropped on Hiroshima, it exploded over Tunguska, Siberia in 1908.
It didn't even hit the ground, but the shock wave from this airburst flattened all the trees and vegetation in the area. It was like a gigantic hand that came down from the heavens to press all the forests and trees. That's the size of the devastation of Tunguska.
If the Tunguska event had occurred over Moscow or New York or Los Angeles, the devastation would have been catastrophic, completely destroying the city and a vast area around it.
And here comes the coup de grace. Notice the failure to say how much money they're wasting on Mars compared to how much money they're spending looking for asteroids.
Though the chances of a Tunguska-type event happening again are remote, perhaps once every 500 years, the potential for a major disaster, if it does occur, can't be ignored. That's why NASA established the Near-Earth Object Program at the Jet Propulsion Laboratory. Its mission is to find asteroids that pose the most serious threats to Earth, the first step in stopping Armageddon.
2032 is 0.02. These are just nominals.
There's a 0.01.
Whenever I'm asked what are the most important aspects of the Near-Earth Object Program, I say, well, the three most important aspects are find them early, and then find them early. Because if we can find them 10, 20, 30 years in advance of a problem, we have the technology now to mitigate them.
The NEO program employs 5 full-time telescopes located across the American Southwest and around the world. They search the skies for asteroids, especially those measuring at least 1 kilometer in diameter, or about 2/3 of a mile and larger. Asteroids that big can cause worldwide devastation on impact.
We can compare the process of finding asteroids to the process of figuring out where a golf ball is going to land after it's been hit. Now just imagine that instead of being able to see the golf ball continuously throughout its entire flight, I only have a handful of freeze-frame snapshots of it while it's moving. And now I've got to figure out where it's going to go. So first of all, I've got to correctly distinguish the golf ball in the frame from all other objects in the frame, say trees or birds, or even other golf balls that may not be the same one. Once I've identified the golf ball in each of the frames, I need to use what I know about the laws of gravity to correctly fit a trajectory to it so that I can figure out where it finally lands. In the same way, when we look for asteroids, we have to just take snapshots of different parts of the sky and distinguish the asteroid from stars, from galaxies, and from any other transient phenomenon like, say, cosmic rays. Then we have to use the laws of gravity to fit a model orbit to it and figure out where it's actually going to go in the end.
No telescopes in the NEO program have found more asteroids than those at Lincoln Near-Earth Asteroid Research, Linear for short. Located in southern New Mexico, they've discovered almost half of the 5,000 known near-Earth asteroids,